Good morning, everyone. Today we're going to discuss the first lesson for Mathematics 7, which is the Introduction to Sets. So I'm your teacher, Sania G. Abilin. Okay, part of the lesson is to discuss the important terminologies associated with the lesson or with the concept about sets. So I hope you keep an open mind while listening to the discussion, to the presentation, as well as you keep with you your ball pen and paper so that you can write down some important terms which you need to remember. Okay, so let's start. So let's first define set. What is a set? Set is a collection of different things having same common property. So examples can be set of number of states in a country, set of different wild animals, set of clothes, set of number of students in class. The theory of sets was developed by German mathematician George Cantor. He first used the concept of sets in problems on trigonometric series. So what is really a set in mathematics? In mathematics, set is a collection of different things such as group of real numbers, group of integers, group of prime numbers, and so on. Examples can be all natural numbers less than 10, all prime numbers less than 20, and the number of vowels in English alphabet. It's important to remember, class, that when we write sets, we use capital letters to denote set and small letters to indicate its elements. In this lesson, we're going to take up the two commonly used methods in writing sets. First, we have the roster method, and second is the set builder notation. So let's take first the roster method. So we have here two examples of sets. We have set A and set B. So as you can see, set A is written in capital letter equals, as you can see, there are two curly braces here, and inside are its elements. We have 1, 3, 5, 7 up to 9017. So this is the set of odd counting numbers less than or equal to 9017. For the second example, we have set B. So we have elements from 1 to 4. As you can see, after 4 there are 3 dots. This refers to ellipses. You call these 3 dots ellipses. So it is the set of all counting numbers. So for all counting numbers, so after 4 we have 5, 6, 7, and so on. Another way to write set, as I mentioned earlier, is by using the set builder notation. Now how do we do that? So we have here an example. We have element of x. We read this as element of x such that x is less than 6 and x is a counting number. So as you can see, we have here a variable x. So this variable x represents any number, any counting number less than 6. So it can be 1, 2, 3, 4, 5. So any counting number less than 6. So this is the same set as 1, 2, 3, 4, 5. So do you think this satisfies the set builder notation here? Of course, yes. All these numbers are counting numbers less than 6. So another one is this one, element of x such that x is a fraction whose numerator is 1 and whose denominator is a counting number. So this time, let's find out how to represent an element of a set. So let's consider the set below. We have set A, which has elements x, y, z. So again, which method is being used here? Is this roster method or set builder notation? Okay, so this is roster method. So since x is an element of set A, we write it in symbol as x, then epsilon A. So this means that x is an element of A. What about when I ask you if W is an element of set A? Is W an element of set A? Of course, no. Okay, so since W is not an element of set A, therefore in symbol it is written as W not element of A. How about there are no elements for the set? So we call that one an empty set or null set, or sometimes we call it as void set, void, V-O-I-D. So it's designated with the symbol, this one, or the two curly braces, empty curly braces. So example, we have set A is an element of x such that x is an even number less than 2. So do we have an even number less than 2? Of course, there is nothing. Okay, therefore, A is an empty set. But how about subset? So let P and Q be given sets. We have these conditions here. Set P is a subset of Q written as like this if every element of P is also an element of Q. Letter B, set P is not subset of Q written as this if there is an element of P is not an element of Q. So in the next slide, we'll take a look some examples on how to represent subset of A. So let's consider the sets below. We have set A, which has elements 1, 2, 3, 4, 5, and 6. Set B, we have 1, 3, 5, and C, we have 3, 6, 9. So when I ask you if is B a subset of A, of course yes, because every element of B is also an element of A. Now let's check if it's true. What are the elements of B? We have 1, 3, 5. And elements of A are 1, 2, 3, 4, 5, 6. So when I ask you, are elements of B 1, 3, 5 can be found in the elements of set A? Of course, yes. So that means B is a subset of A because every element of B is also an element of A. Now, what about C? Is C a subset of A? Now let's check their elements. C has elements 3, 6, 9. And A again has elements 1, 2, 3, 4, 5, 6. Okay, so C, there are two numbers here, 3 and 6, which can be found in set A. But 9 cannot be found in set A. Therefore, C is not a subset of A because 9 is an element of C but is not an element of A. So that's it. Okay, we already understood what subset is. This time, we'll go to proper subset. How does it differ from subset itself? Okay, proper subset of a set is a subset of A that is not equal to A. In other words, if B is a proper subset of A, then all elements of B are in A, but A contains at least one element that is not in B. So for example, you have, if set A equals 1, 3, 5, and set B has elements 1 and 5, therefore B is a proper subset of A. In symbol, we denote it like this. So what makes B a proper subset of A? Because of the element 3 here. Okay? So based on the definition, B can only be a proper subset of A if all elements of B are in A, but A contains at least one element that is not in B. Another thing to consider is the equality of sets. How can two sets be equal to each other? So equality of sets is defined as set A is said to be equal to set B if both sets have the same elements or members of the sets. Okay, take note. A is said to be equal to set B if both sets have the same elements or members of the sets. Example, if each element of set A also belongs to each element of set B, and each element of set B also belongs to each element of set A, therefore set A and B are equal. Okay, let's take these examples. We have set A, which has elements 2, 7, 5, and set B, which has elements 2, 5, 7. So the question is, are they equal? Yes, because B is a subset of A in which all elements of B are also elements of A. So they are equal. In symbol, this can be written as A equals B. So another example is this one, the sets A and B, in which A has elements 2 and 5 and set B has elements 2, 5, 7. So they are not equal because B is not a subset of A. So we could write it as A not equal to B. As you can see, A has 2 elements only while B has 3 elements. So these two sets are not equal. Another important term that we need to take note when we talk about set is the cardinality of a set. So take note of the word cardinality of a set. So this refers to the number of elements within a set. So in this example, we have set A, we have 3 elements for set A, and for B we have 2 elements. So in symbol, we write the cardinality of set A as this, which is equal to 3, and the cardinality of B, which is equal to 2. Okay, so I think that's very easy to remember.